Hello and welcome to a new webinar. Our topic today is how AC/DC rocks your electric vehicle, introducing the T6 for auxiliary drives. I hope everybody can see and hear us.
Maybe someone could confirm this in the chat.
Okay. Yes.
Okay.
Okay. At first, my name is Daniel Schroeder. Next to me, my colleague Boris Schneider.
Hello.
At first, a short introduction to my person. I am new in the T6 e-mobility team, and I supported Boris with programming software for the T6. And today we will show you something about the T6 and its app utility. I share my desktop. Okay. And genau. The topics for today are the app utility and the apps can open app, the torque speed control app, and the possibility of a custom application app. Furthermore, we will show you upcoming features, for example, UDS and new apps. If you have any questions, you can directly write it down in the chat. We can see that. And at the end of the presentation, we will answer some of the questions. And now I would like to hand over to Boris. One moment. Okay, now you can start.
Okay, thanks, Daniel. So I try to share my screen and also my test bench. Okay, I think it is visible. Can we also see my desktop? Can someone confirm this again, please, before I start?
Yes.
Okay. Yes. Okay. Good. So, as Daniel already said, today I want to present the app utility. The app utility is the software that is located in the MCU of the T6. So today's topic is not the, let's say, inverter itself. It is the control part who's on top of the inverter and does all the handling and the communication to the vehicle ECU. For this purpose, I choose two apps, mostly because of the reason that they are very different. The torque speed control app is a very basic app that is based on J1939 communication and just on torque and speed control of the inverter. While the Can Open app is a totally different protocol. It's more a protocol that is common in the industrial area, but we saw that some of our customers also wanted to use the T6 via Can Open, so we implemented an app that could resolve this this demand. And with the app utility, you can basically choose which app is active on which node. And this is what I wanted to present today. So the test bench that we see over here on my right side is right now a T6 that is in the exact delivery state. At least in terms of the MCU, I already prepared the DCUs, so the axes are already up and running and ready to go. Just the MCU is still in the original state, in the delivery state. And now I can access the parameters of the MCU via our main tool, which is CombiVis. And over here we see the default settings. In default, all nodes are activated with the torque speed control app. This is basically our default app. It's a very simple app. It just allows you to adjust the torque and the speed of an axis via Can Open with a very simple CAN topology. So over here we can see the main settings. I don't want to go too deep into this. This is something you can also check in our manual, which would be available if you press here on this question mark and you get the manual for the software. Over here we have the address 80 set up for our node. And if we now change into the node settings, in the inverter settings or inverter specific settings, basically, you can see that there is the torque speed control app selected over here for this node. And there is some basic setup in this app. For example, we have no source address filter. We have the cycle rate of the process data for 250 milliseconds. And over here we can see how the process data look like. So for example, in the command telegram that the ECU is sending to the T6, there's just a control mode which defines what we want to control. Like, do we want to control the velocity? Do we just want to control the torque? Or do we want to control both at the same time? So we have velocity mode, torque mode, and mixed mode. And of course, the velocity values and the torque values. These are the only values that are in the CAN frame for the command values or for the requested values. It's pretty simple CAN telegram. And to be able to control this now, I reassembled and simulated ECU in my CAN OE environment from Vector. So over here we can see our simulated ECU, and this here is the T6. This is basically grayed out because it is not active in the simulation. The T6 is an active part and real part in this scenario. So I created a little GUI to be able to control the CAN data, but I can also just log in for a presentation and show the CAN trace. So what my simulated software is sending here is these frames here. These are 6 different frames, and basically it's designed to control 6 different nodes. My test bench here only has 3, so these frames here would be irrelevant in general, but it's an worst case setup that I created over here. It's nothing I created specially for the presentation. So in these frames here, there are my set values that are sent to the T6, and I can change these set values with this graphical user interface here. So as you've seen before, I have access to the mode, and over here to the velocity and the torque. I will now set my first node to speed control. This will change the CAN telegram that is sent to the T6, and it's already starting up, as you can see in the camera. And I just want to repeat, the MCU is in default state. I did not change anything. I just used the default setup, and the inverter is directly ready to go. Of course, the inverter needs information about the motor, but this is already prepared in this case. But the MCU is in delivery state and can be, if you use the torque speed control app, it's pretty easy to get the first reaction of the drive. So I will also start up the second one and the third one. And you can see all the nodes are already reacting to my commands. I can also reverse the velocity. I could also go to torque mode. I will not do this right now because as there is no load on my motor, it would fire up to an extreme high speed. And this is not really a good presentation then. Okay, so all my nodes are now listening to this ECU and following the commands that I'm sending over here. I will now switch them off again. And a key factor for the whole app utility solution is that you have the possibility to change the behavior of every single node. So for that reason, I will now change the behavior of node 3 and select a different app. I will now go to the CAN Open Slave app. And now I also get a different screen over here, which displays me the parameter that are necessary to set up for CAN Open. If you switch the app like this, it's always very important to check all the settings, because the different apps use the same parameter cells. So it could be that there are settings from the previous app still in place, and they have a different purpose now, so they need to be rearranged. The baud rate that I want to use for CANopen is 250. We want to access port 0, and my node ID will be 1. Timeout reaction is fine like that. As you can see, I can define the CAN port over here, so it will also be possible to say that I use my J1939 on CAN port 0 and do like 2 of my 3 nodes via J1939, and my CANopen slave will be on the second CAN port of the T6. So I would have a split between these different networks. In my actual hardware, I only have 1 CAN wire, so I will go for a mixed mode. Probably not the cleanest one, but it's today just for presentation purposes. So that means when I set this setting here into the T6, node 1 and 2 will still be active with J1939 and will still be active as a torque speed controlled axis. But node 3 is now switched to a complete different behavior with a different app, which is the CANopen slave. To activate the settings, I need to reboot the T6 once. Can do this with this button over here. So T6 is rebooted and should be ready to go again. Okay, the red indication here just shows that he's missing some CAN telegrams because I switched off my simulation. Let's switch it back on. And now I fire up these axes again. And as you can see, my node 3 does not create any response of the axis anymore. The node is not listening to these commands anymore because we basically switched from torque speed control J1939 completely to a different protocol, to a different behavior, to a very individual behavior for this node. So of course I choose CANopen for a good reason, because KEB is also in the industrial field very strong, and we have applications and software that can run the CANopen stack. So I used a little sample project here that is normally used to fire up one of our industrial inverters that is based on CANopen. And if I start this project now, you can see that these nodes here are getting green. This basically indicates that my CANopen master, which is a little industrial controller that is here on the bottom. You can't see it, but I guess you can trust me in this. So there's a little CANopen master connected to the same CAN bus like my laptop and the CANoE, and is firing up a CANopen slave, which is visible over here. And as it is already indicating green, it basically shows communication is active and communication is done. We can also see over here that the node went to the green state before it was on yellow. It was basically waiting for the commands of the CANopen master. But now the slave is operational and the communication is active. We take another look in the trace. We can see, I gotta switch the display a little bit. We can see that there are now some telegrams in here that are usually not there, because these are 11-bit telegrams and these here are 29-bit telegrams. We could now discuss if you should mix something like this, but in general, it is possible and it is working. If it is a clean solution, it's another topic. But as I already said, for demonstration purposes, I'm fine with this setup right now. So and now I can try to control the T6 via the CANopen with a little GUI that I created on this side. someone who already knows CANopen is probably seeing that this is CIA 402 standard. So the T6 is also following this standard. And everyone can see that the axis is now moving. I will make it a little faster. And this is now done via a command that is sent via CANopen. Of course, the J1939 is also still available and active. And you can see now that I'm controlling now node 1 and node 2 via a completely different protocol, and they are responding in a complete different behavior than the node 3, which is controlled here by CANopen. The T6 also resolves the typical CANopen functionality. So just for demonstration, and because I think it works pretty well, I want to show that also positioning mode is possible. We do not have an encoder on the T6, but you will see that the result is, considering that we do not have a real measured position value, is very accurate. So I will go for, let me switch off these other nodes so we're not distracted from the node 3. So I will set up a positioning velocity of 1500. And this here is basically with the actual resolution rotations. So I can say now, I enable operation, let's say relative mode, and we want to have 10 rotations. And you can see that the axis moved for 10 rotations. Okay, maybe we couldn't count the rotations, but you can see that the resulting position is basically ending in the same spot that it started. And I can repeat this a lot of times and it will be very accurate result. So for relative positioning, T6 could be an option. And I think this is a cool feature considering the fact that there is no encoder installed in the device. We will see if there's a demand on the market for this, but for the T6 at least, it's not a problem. Okay, so today I showed two different apps. I presented you the CANopen app and the Talk Speed Control app, but the key factor on this concept is that the amount of apps is barely limited. Of course, we are limited in some kind of memory consumption, but we can place a lot of apps before we reach this limit. So the functionality of the T6 will rise over time more and more with every app that is created. And it is also possible to create your own app. So you can go into the programming environment, create your own application, your own function block that resolves the behavior for one node. And in the settings, you can select the custom application. And this will fire up the function block that you created in your private environment. And in the end, if you're happy with the functionality of the application, you could come back to KEB and we will place your specific app into the list of available apps that the customer can choose from. So this way also customer specific applications can be spread it out to all the customers who use the T6. Okay. That's actually already what I wanted to show about the application utility. But because I still have some time left and I also already mentioned it on the agenda, I also wanted to show something about UDS. That's a new functionality that we are working on the T6 right now. And I would say it's close to be available or close to be released. So what I can do now here is I go back into my CANoE. In the CANoE, I placed the description file for CanOpen from the Candela tool that I entered into my CanOE environment. And now I have here two pages, one for the MCU and one for the DCU. And now I can access data. For example, let's say I want to have information about the voltages. I can see that there is the actual DC voltage in the inverter is 532 volts. I can access temperature informations, like here, 21 degrees on the heatsink, the internal temperature. Motor temperature is not that high. 2000 indicates that there is no sensor connected. So 2000 degrees, luckily, is not the case at the moment. And like this, I can get a lot of different informations from the system. And I do not necessarily need CombiVis. Of course, I would recommend to use CombiVis in any case, but in some case you want to have a standardized way of making diagnoses, and in this case, UDS is probably a good solution. You can also drag out the error history and all the informations about errors like this via the UDS tool, and so on. In the future, it is also possible to update the MCU software via the UDS tool or via the UDS channel. This will allow us to create new versions for the application utility, and these new versions would contain new apps, and you could place this on your device via UDS standards and UDS tools. Okay. What was on the agenda as well?
I can have a look again.
Yeah, the new apps.
New other apps.
Okay, so at the moment, the list of apps is not that huge. You probably already saw it over here. So we have 5 different apps. One of these is basically no functionality. It's just placed for service purposes. So, and these 4 apps here are all very generic. They do not point to a specific application. They are a universal application that can be used for velocity control and so on. But the key factor behind the app utility is basically that you can create closed up systems with the T6. Means if you have a steering pump and the T6 is used to run the motor of the steering pump, you can create an application that allows you to have a topology that the ECU sends you demanded steering support, or maybe demanded pressure for the steering support, or whatever, instead of sending a velocity value. And the calculations and the resulting velocity can be calculated inside of the T6. The same is, for example, for a heating pump. If you have a heating pump to control your climber in your vehicle, you can demand a temperature for your environment instead of demanding a velocity for the heating pump. And all the regulations and the loops that are needed to create a temperature out of a velocity will be embedded inside the application software of the T6. And like this, the add value of the applications rise depending on the complexity of the application that the T6 is resolving. So there are different apps already in work at the moment. I can just say that, for example, we are working on an app that, or let's say we are working together with the with customers that produce steering pumps or air compressors or heating pumps. So in the end, KEB is not the one who is creating this software in particular. Instead, we support the manufacturer of steering pumps and air compressors to embed this add value and this logic inside the T6. And we are at the moment working on a heating pump software, on a steering pump software, and on an air compressor software. And of course, we are open for more projects and for more applications that can be placed in the T6. So if there is a demand on the customer side for an very unique or special solution, they can always come to KEB and describe the demand, and we will see how we can solve these requests in our system. Okay, half an hour, a little bit faster than planned,
Yes.
but I think it's fine. Are there any questions in the chat?
Okay, thank you, Boris, so far. Let's have a look at the chat for the questions. Okay, there's one question. What other apps are available?
Okay, I already talked a little bit about this, but maybe we can take a little deeper look in it. So we already saw the Talk Speed Control app. It's basically a J1939 based app that is just made for controlling speed and controlling velocity and controlling torque. An alternative to this would be the Process Data Gateway. In this case, the app is not describing the functionality of the system. Instead, the app will just forward CAN data to the inverter directly. And this way, you could solve positioning requests or make your a raw torque control, or basically every functionality that can be resembled with the T6 could be just forwarded to the CAN bus. Another app is the Drive Mode. It's a very extremely simple app. It basically, you set a fixed velocity over here, and the motor will just fire up as soon as the KL15 on the low voltage input connector is set. So there is no CAN telegram necessary at all. You can just set a fixed velocity for a node, and it will start up as soon as the key is turned. This can be helpful, for example, if you want to create 50 Hertz artificial net on your vehicle, and there shouldn't be anything stopping this network. So you just say, as soon as the key is turned around, everything is starting up. And of course, the last one, the CAN Open app. It basically supports the T6 nodes, similar like an industrial inverter. There are some limitations that can be read here in the manual regarding the process data, for example. You can find a list which data are available for process data. It is not every parameter of the T6, but I would say all that are necessary. And this is the amount of applications that are available so far. Mm-hmm. And of course, the applications that I mentioned that we are working on, and they will be added in a hopefully soon future.
Okay, thank you, Boris. Another question is the wizard with the graphical interface standard?
Yes, but the wizard is at the moment not a default installation part of CombiVis. So if you want to work with the T6 and you want to have access to this wizard that you can see over here, you can contact your KEB partner, your KEB contact, and request the wizard, and it can be installed via the package manager here, and we will send you a small file that will just be installed like this. We are working on a long-term solution that will include the wizard also in the regular setup, or it will allow you, when the setup is executed, to choose if you want to have the wizard installed or not. But for the moment, it's not a default feature from CombiVis.
Mm-hmm. Okay. Okay, that was it. There were no other questions. Thank you, Boris, for the presentation.
Yeah, thank you, Daniel, for your moderation.
Thank you for your attention. And if you have any further questions, please do not hesitate to contact us. You can write an email to webinar@keb.de. Yes, okay, that was it.
Have a nice day, everyone, and stay healthy. Goodbye.
Okay, bye.